In this video, we'll look at rational functions as transformations. So this is the first step towards being able to graph a rational function, an arbitrarily complex rational function. We'll start pretty simple, thinking of rational functions as transformations of the kind of base function 1 over x. We'll look at a quick problem, and then this will lead us into a discussion in the next video about asymptotes of rational functions. So first, what is a rational function? Well, you may think, when you hear rational, you may think of numbers that look like p over q, right? This could be 1/2, this could be 7/18, this could be anything that looked like that. So it would follow that a rational function is a function of the form r of x equals p of x over q of x, where p and q are polynomials. In this case, we'll assume that p and q have no factors in common. And as we know from looking at the function 1 over x, even though rational functions are constructed from polynomials, their graphs are very different from polynomial functions. So if we want to start simply and then kind of build this idea up, we should start with the most basic rational function, r of x equals 1 over x. And to start this discussion, we'll look at graphing it. So we'll graph it, we'll come up with the domain and range, and then this will also lead us into our discussion in the next video of asymptotes. So we could do our typical t-chart. We could do x and r of x. If we plug in 1, we get 1. If we plug in -1, we get -1. 1/2, we get 2. 2, we get 1/2. -1/2, we get -2. And -2, we get -1/2. So we'll plot all those points. Here, 1, 1, 1/2, 2, 2, 1/2, -1, -1, -2, -1/2, and -1/2, -2. So this makes me think about something. Like, as we get close to the y-axis, like let's say we start on the positive side and we have a positive number that's getting really close to 0. So that's like saying that we have 1 over something really small, and we get something big out of that, right? So the smaller the number is, the bigger 1 divided by that number is. So this part of the graph goes up like that. And similarly, 1 over something big gives us something really small. And as it gets really, really big, the output gets really, really small. So we go like that. And this pattern is true for the negative side of the x-axis. So our basic rational function looks like this. Now you may notice, of course, that we have asymptotes at x equals 0, that one there, and y equals 0, that one there. So now that we have a graph of the function, let's find the domain and range. When we see this, obviously we can't be dividing by 0, so x equals 0 is outside of the domain of r. But we can hand it pretty much any other number, right? So we can say that the domain is going to be the real numbers except for 0. And when we look at the range, we see the same thing. We see the same kind of pattern. So we say that the range is the real numbers except for 0. Now that we have our base graph, r of x equals 1 over x, our simplest form of a rational function, let's talk about transformations. So you may remember that, like, we use f of x, the base function, equals 1 over x, and then we do transformations off of that to help us identify what things are happening to the base function. So in the standard form, a f of b x minus c plus d, we might end up with something that looks like a over b times x minus c plus d. The a's are the vertical stretch and shrink, b is the horizontal stretch and shrink, c is the horizontal shift, and d is the vertical shift. Now let's put it all into practice. Let's graph the rational function 3x plus 5 over x plus 2. Now when you see this, you might think that doesn't really look like 1 over x. It doesn't in this form. But now we can use our division skills to simplify it a little bit. So we'll say we're dividing x plus 2 into 3x plus 5. What do we need to multiply x plus 2 by to get 3x plus 5? We need to multiply by 3. So that gives us 3x plus 6. And we subtract, leaving us with -1. And now we rewrite r of x as -1 over x plus 2 plus 3. So now it happens to look like a transformation of the base function 1 over x. And if we let f of x equal 1 over x, then r of x equals negative f of x plus 2 plus 3. And the reason we want to write it like this is to make clear what transformations we need to do to go from 1 over x to our rational function -1 over x plus 2 plus 3. So let's graph 1 over x first. We know that looks something like this, and this, with asymptotes at x equals 0 and y equals 0. So now we can see that, all right, so we need to flip the thing over its axis. We need to move it 2 units to the left and 3 units up. So I think for graphing transformations of a rational function like 1 over x, it's most useful first to move its asymptotes. So first we'll move its asymptotes 2 units to the left and then 3 units up, which will put it right there. That's kind of the center, like that. And then remember that it's also flipped over that midline, which means that the negative side is going to be on top and the positive side is going to be on the bottom. So we will look like something like this. And that's kind of how you graph a rational function, using transformations of the base rational function 1 over x. So in the next video, we'll talk a little bit more about asymptotes of rational functions, what an asymptote is, how we talk about them, how we write about them, and some special cases.